All right, let's talk shop. If you're an energy efficiency pro, you already know that lighting is almost always the best place to start an audit. It's the low-hanging fruit. So today, we're going to skip the 101 stuff and dive right into the core formulas you absolutely need to quantify, justify, and truly optimize any lighting retrofit project. Let's get into the numbers.
So here's our game plan. We're going to walk through this just like a real-world professional audit. We'll start on site, assessing what's there. Then we'll move into the design phase, build a rock-solid financial case, analyze all the ripple effects, and we'll wrap up with the core electrical principles that tie it all together.
Okay, first things first. Picture this. We're on site, clipboards in hand. Our first job is to get a hard baseline of what we're dealing with. We need to quantify exactly how the current system is performing. No guesswork.
And that brings us to the fundamental starting question. This is the diagnostic, the one question that points us directly to our biggest opportunities for savings. And to answer it, we need our first key metric. And that metric is efficacy. Think about like MPG for light sources. It's our core performance number, and it's simply the total lumens, the light output, divided by the watts it consumes. A higher efficacy means you're getting more light for less energy. This one number is our best friend for spotting the easy wins in any facility. And here's a perfect example of what to look for. A classic 100-watt incandescent bulb puts out about 1,750 lumens. Do the math, and you get a dismal 17.5 lumens per watt. I mean, when you know a modern LED can easily top 150 lumens per watt, a number this low isn't just a red flag, it's a giant flashing neon sign that says, "Save money here."
Okay, so we've identified our energy hog. But a professional retrofit isn't just about a simple one-for-one swap, right? That's amateur hour. It's about designing a system that delivers the right amount of light exactly where it's needed. And to do that, we have to calculate the precise number of fixtures we need. For that, our tool of choice is the Lumen Method. Now, this formula might look a little intense, but it's our best friend for right sizing. N, the number of lamps, equals your target lux level times the area of the space. Then you divide all that by the lumens per lamp, the coefficient of utilization, or CU, and the light loss factor, or LLF. Getting this right prevents the classic mistake of overlighting a space, saving the client even more money. So about that coefficient of utilization, the CU, how do we get an accurate number for that? Well, that's where the room cavity ratio, or RCR, comes in. You just plug in the cavity height, H, from the fixture to the work surface, and the room's length and width. It spits out a single number that describes the room's geometry. Then, you just take that RCR number to the fixture spec sheet, and it tells you the correct CU to use. This is the secret to a really precise design. All right, so the technical work is done. We've assessed the site, we've designed a smarter system. Now comes the most important part, translating all our brilliant engineering into a financial proposal that the CFO can't possibly turn down. The business case always starts with the raw power reduction. The kilowatt savings formula is simple. It's the number of lamps you're changing times the wattage difference divided by 1,000. But here's the key takeaway. This isn't just about energy use over time. This is about slashing the peak electrical demand. For so many commercial clients, that's where the biggest savings are hiding on their utility bill. And here's how we turn that reduction into cold, hard cash. Your annual demand savings are just your kilowatt savings multiplied by the utility's monthly demand charge times 12. Seriously, for some industrial clients, this demand charge is a monster. Showing them this number can be a real eye-opener. Next up, we calculate the energy consumption savings. This is the one everybody expects to see. It's just our kilowatt savings times the annual operating hours times their cost per kilowatt hour. This calculation is really the bread and butter of any energy project's justification. But a true expert goes deeper. The total annual savings is your demand savings, plus your energy savings, plus other savings, and minus any additional costs. These other impacts, things like HVAC and maintenance, are exactly what we're going to break down next. And all of this work, all these calculations, they all culminate in this one beautiful number, this simple payback period. Just take the total investment cost and divide it by your net annual savings. This is the punchline. It tells management exactly how fast they get their money back. And the best part about lighting projects? This number is often incredibly short. We're talking a year or two sometimes, making it one of the most compelling projects you can ever propose.
Okay, so let's dig into those other savings I mentioned. This is where we really show our value, by looking beyond the light fixtures and analyzing the ripple effects across the entire building. I'm talking about HVAC and maintenance.
Now, when it comes to HVAC, it's a two-sided coin. More efficient lights produce a lot less heat, which is fantastic news for the air conditioning load in the summer. But that also means the heating system might have to work just a tiny bit harder in the winter. A thorough analysis has to account for both sides. Let's start with the big win, AC savings. You calculate this by taking your lighting kilowatt savings, multiplying it by the annual AC hours, and then dividing by the AC unit's efficiency, its coefficient of performance, or COP. For most commercial units, the COP is around 3.0. In warmer climates, this bonus saving can be a huge factor in getting a project approved.
On the flip side, we have to be honest about any potential heating penalties. This formula looks complicated, but all it's doing is converting the lost heat from the old lights into the BTUs the furnace now has to make up, factoring in hours, efficiency, and fuel cost. Including this in your report shows you've done your homework. It builds credibility and proves you're a true expert.
Now, let's talk about maintenance. You basically have two strategies. Spot relamping, which is reactive. You run out and change a bulb only when it dies. Or group relamping, which is proactive. You replace all the lamps in an area on a planned schedule. Group relamping is almost always the smarter financial move, but we need the numbers to prove it. And here's the proof. For group relamping, your annualized cost is the lamp cost plus the group labor cost, all divided by how many years the lamps last. This formula shows the power of economies of scale. You're buying in bulk, getting the crew in the lift out there just once, which dramatically lowers the per-lamp labor cost. It's just a smarter way to work. Now compare that to the cost of spot relamping. It's just a lamp cost plus that much higher one-off labor cost to replace a single failure. When you put this number right next to the annualized group relamping cost, the business case for a proactive maintenance plan becomes an absolute no-brainer. All right, for our final section, we're going to zoom out one last time and look at how our lighting system impacts the facility's entire electrical load. We're getting back to some fundamental electrical principles here. We've all seen this formula for AC power. Watts equals volts times amps times power factor. Now, for lighting experts, that power factor, the PF, is a huge deal. Old magnetic ballasts had terrible power factors, sometimes as low as 0.5. That means they were drawing twice the current they actually needed, forcing you to have oversized wiring and often getting you hit with penalties from the utility. Modern electronic ballasts, they have a power factor close to a perfect 1.0. They use power way more effectively, which reduces the load on the entire electrical system. So there you have it, the complete workflow, from calculating efficacy and designing the right system, all the way to building the business case and analyzing the holistic impacts. You've now got the entire quantitative toolset to go out there and tackle any lighting project with total confidence. So the only question left is, which system are you going to go optimize first?